Hey friends, in this video, we are going to explore the equation of a circle. Let's start by looking at this circle. Just based off of the figure, I can tell you exactly where the center is of this circle. The center is right here at the point 1, 2, and I can even count the radius. So it's a little bit hard to count this way, so it's probably easier to just count this way, and I can see that the radius is 3. I can also determine the diameter and the circumference, but we did that already. That was in another video. Today, we are going to add another layer to this. We're going to talk a little bit about the equation of a circle. So what you see on the screen right now is the standard form for the equation of any circle. It's going to have a parentheses with an x and a number. It's going to have another parentheses with a y and a number, and it's going to be added together and it will equal a squared number. So let's look back at our first circle. This is the equation of that circle. We knew that the center was at 1, 2, and that the radius was at 3. So what do you notice about the equation, the location of the center, and the radius? Let me give you a second to think about it. What about for this example? What do you notice about the center and the radius? Look at the equation for this circle. Well, I do notice that the center is at -3, 2, and that my radius is also 2. Look at how that connects to the equation. So I know some of you have noticed that the center and the radius are part of this equation. The center will be located here with my x-coordinate and here with my y-coordinate. My radius is always going to be the solution to this, but the radius will be squared. So it might be helpful to have a little list of square numbers and their charts. Because for example, if my radius is 7, my solution will probably not say 7 squared. It'll probably say 49. So let's look back at that first example. Let's see how we can connect the center, the radius, and the equation. I see that here I am subtracting 1 and subtracting 2. Well, that tells me that my center is going to be at a +1 and a +2. And if I look on my graph, that's exactly right. I also see that the equation is equal to 9. Well, I know that 3 times 3 is equal to 9, so my radius must equal 3. And if I look on my graph, sure enough, it's 3. Let's look at the second example again. In the equation, I have a +3, so x is being added 3 and y has a subtracting of 2, and I know it's equal to 4. Well, I'll start with the 4. I know that 4 is equal to 2 times 2, so my radius must be 2. And if I look on the circle, it is 2. For the center, I'll need to use the numbers that are with the x and the y in the parentheses. So my center must be at -3, since this was a +3, and a +2, since this is a -2. So my center is at -3, 2. Let me check. Back 3, up 2. Yep, that's right. Let's try one without a picture to check. Start with my 16. I know that it will always equal the radius squared. So what number could my radius be? That's right, 4. I know that somewhere on this graph, I'm going to have a circle with a radius of 4. Let's find the center of it. So with my x term, I see -1, so I'll have to use a +1. And with my y term, I see a +2, so I must be needing a -2. So my center is going to locate at 1, -2, that's right here, and a radius of 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And I'm going to draw the world's worst circle. That's why I became a math teacher, not an art teacher, in case you did not know. So we can totally see how the equation, the center, and the radius are connected. So let's do a quick little summary check. Remember, the solution to my equation is always going to represent the radius. It's going to be squared, so you might want to keep track of your square numbers. These two numbers here are going to tell me the center, and they're always going to be opposite of what I really need. So I have 3 equations here. See if you can determine the center and the radius with me. My first equation says x minus 7 squared plus y minus 2 squared equals 16. The radius is easy. 16 means that my radius is 4. And my center, I'll use these numbers here, and it's going to be at 7, 2. For the second example, x plus 5 squared plus y minus 3 squared equals 25. So the center of this circle is going to be at, -5, comma, 3. And the radius of this circle will be 5, since 25 is 5 times 5. So for this last one, I always get the question that, oh, I think you forgot a number. There's no number with your y. There actually is a number with my y. That number is 0. So my center will be at +7, 0, with a radius of 9, since 9 times 9 is 81. I think you got it now. We've got a few examples there. Remember, it is all connected. The radius and the center and the diameter and the circumference, because the radius gives me the diameter gives me the circumference goes around the center has an equation. The circumference goes around the circle. It doesn't go around the center. It's a really nice day outside. Sorry, I messed up. But it is all super connected. And so now I want to give us some chance to practice. Stop right here. I'm going to give you an opportunity to go back to my MCPS classroom or go to Google Drive and get the practice worksheet that goes along. Or you can totally follow along and pause 75,000 times as we go through 4 different examples connecting the radius, the diameter, the circumference, the center, the equation, and the figure. I want you to do your best Oprah impersonation. You get the worksheet. No, you get the worksheet. No, you get the worksheet. Press stop right now and get the worksheet and come back and catch part 2 of Equation of a Circle.